Hello students, welcome back to my YouTube channel. This is Kashima Soni and today we are going to take up the next ionization method in this particular series of mass spectrometry, that is chemical ionization method, and possibly we are going to discuss the rest of the ionization techniques as well. So without wasting any more time, let's switch to that particular part. But before jumping to that, let me make a request to you to kindly switch to the first part of the video in the series of mass spectrometry that I've already uploaded. I request you to just go over there, check that once, and then switch to this particular part. Okay, so without wasting any more time, let's go further. Alright, so these were the ionization method that we were supposed to discuss in the mass spectrometry, correct? So the first electron ionization and electron impact method that we have already discussed in the previous video, the first video of mass spectrometry series. So the link is mentioned in the description box. Check that first and then switch to this part. Today we will be taking up first chemical ionization possibly, and also we will be taking up these two ionization method as well. So alright, so the second ionization method is going to be your chemical ionization method, correct? So what is happening in this particular case, your sample molecule is going to get combined with the stream of ionized reagent gas, or you can call it as your carrier gas also, okay? It is present in great excess relative to that to the sample. So what is happening? Your sample is introduced into the ionization chamber near the atmospheric pressure with the large excess of the carrier gas. It could be methane, it could be ammonia, it could be isobutane, okay? And talking about these three reagent gases, we are going to take each of them as an example over here, and we'll be discussing that in detail. Okay, so what is happening when the sample molecule is getting collided with the pre-ionized reagent gas? Some of the sample molecules are ionized by various mechanisms, including proton transfer, electron transfer, and adduct transformation. So these three mechanisms will be seen in the next very slides. Okay, and almost any of the readily available gas or highly volatile liquid can be used as a reagent gas, and specifically we are going to talk about methane, ammonia. Okay, just let me remove it. Methane, ammonia, and then comes your isobutane. So we'll be taking these three as an example over here. Okay, so first of all, let's talk about your methane. When it is used, it has been used as a reagent gas in CI technique. Alright, so you can see over here, your methane gas is first getting ionized in the ionization chamber like this, resulting in the formation of primary ion. So this CH3 radical cation over here is nothing but a primary ion. Okay. Now what is happening? This primary ion is again going to act with excess of the your reagent gas or carrier gas, that is methane, present over here, and resulting into the formation of your secondary ion, that is CH5 plus ion over here, and a radical your methane radical is released as such. Okay. Alright, so that is another method. And what is happening? This secondary ion that is formed, CH5 plus, it is going to react, or it will be reacting with the analyte molecule, and it will further form ion via three ways that we have discussed in the previous slide. Okay, I'll show you these three techniques via proton transfer, electron transfer, and adduct transformation, that we'll see how. Correct. So this is one thing. Also, this methane radical, if will be reacting with your, if you are going to see it getting decomposed, it can get fragmented like this. So this is also a sort of primary ion only, this CH3 plus. So if it is reacting with excess of methane gas, it is also now again going to form your secondary ion, that is your C2H5. Okay, so secondary ion over here is CH5 plus and C2H5 plus, and these two secondary ions, they are going to react with your analyte molecule or sample molecule and form ion via three ways. That is, one is your proton transfer, another one is your hydride transfer, and last one being your adduct formation. Okay, so that is three methods, and some of them have already been discussed over here. Let me show you how it is happening in case of the three methods that I have mentioned over here. So the first reaction over here is this one, is your proton transfer only, where your metal is reacting with the CH5 cation, CH5 plus cation, that is your secondary ion, okay, and it results in the formation of M plus H positive plus CH4 is released as such. So this here it is occurring proton transfer from this particular cation to your sample molecule M, okay. So that is the process proton transfer only, and here you can see the another process, that is your hydride transfer. You can write this reaction as like this, or you can continue writing it further like this, and it can be written like M minus 1 plus C2H4 is released. So here what is occurring? Hydride transfer is occurring. Understanding? From this molecule there is occurring hydride transfer. What is happening? This particular molecule, sample ion, that is that you can see that molecular ion formed over here, they can lose hydrogen to give prominent M minus 1 ions. Okay, they can lose hydrogen to give prominent M minus 1 ions. Understanding? That is one method. So that is how you can use CH4 methane as a reagent gas. If questions could be asked in your subjective paper, you can mention all these things wisely and properly, and you'll get your required answer. So the two methods that we have seen, proton transfer and hydride transfer mechanism that we have seen. If you want to write down about the adduct formation, you can write down over here only. Adduct formation, how you are going to do it, okay. Write it like this, where your sample molecule is reacting with your CH3 plus cation, that is this one primary ion, this one primary ion, and it results into the formation of something like this, M minus CH3 plus, or you can write down, or see, CH3 is having molecular weight 12 plus 3, 15. So you can write it like this, M minus 15 plus. Understanding? That is the mechanism adduct formation. So proceeding further. Similarly, you can see the situation is quite similar with the ammonia gas as a carrier or reagent gas. Okay, same process is occurring. Ammonia on getting ionized, it results in the formation of this radical cation, and this radical cation will reacting with the excess of ammonia, resulting into the formation of this particular primary ion and this radical, okay. And now what is happening? Your sample molecule or analyte is reacting with this particular ion, that is you can also call it as quasi-molecular ion, and it results in the formation of this particular ion, that is M plus H positive, and ammonia is released as such. Similarly, you can see the isobutane as a reagent gas example also. So we will be proceeding further to the next ionization method. But before that, let's see what is happening in this process only. See, varying the reagent gas in this particular process, it allows one to vary the selectivity of ionization and degree of ion fragmentation as well. Understanding? So you will have to see which reagent gas has been used in the particular method of chemical ionization, correct? So that is how you understanding the degree of ion fragmentation as well. So what is happening? Greater the energy difference between the proton affinity of the sample and that of reagent gas. I repeat, greater the energy difference between the proton affinity of your sample and that of reagent or carrier gas, the more energy is transferred to the sample during ionization. See, now sample is having more energy. That means due to this excess energy that has been produced to your analyte or sample ion, in the higher it produces your sample ion to the higher excited vibrational state, and if it is now in the higher vibrational state, what is happening? The sample ion will get fragmented through the cleavage of your covalent bonds. So this is what is happening right now. And then the ionized reagent gas is also detected sometimes by spectrometer, and because the reagent gas is present in great excess relative to sample, the ions would dominate the spectrum. So what is happening? जो आपका reagent gas होगा, ionized reagent gas जो होगा, it can also get detected by your mass spectrometer. And what is happening? Because this reagent gas, it is present in excess as related to the sample. So जो आपके reagent gas की जो ion आयंस होंगे वो आपके डोमिनेट करेंगे स्पेक्ट्रम में. ओके, सो कई बार आपको आपके मास स्पेक्ट्रम में इंस्टेड ऑफ योर पर्टिकुलर सैंपल आपको डेफिनेटली सैंपल की पीक्स देखने को मिलेंगी, बट उसमें आपके साथ ही साथ आपके जो भी रिएजेंट गैस यूज हुई होगी उसकी भी peaks आपको देखने को मिल सकती हैं. Understanding? So yeah, that's about it. And proceeding further, so let's discuss about the advantage of your chemical ionization technique. See, the main advantage is the selective protonation of intact quasi-molecular ions. These are such of your quasi-molecular ions. You can write it like this as well. So what are quasi-molecular ions? See, the ions that have been formed by the loss of proton from a molecule. Okay, understanding? The ions that have been formed by the loss of proton from the molecule, that is your intact quasi-molecular ion. So you can write it like this as well. And the main advantage that we have already discussed over here. Another advantage is it is inexpensive. This particular method is inexpensive and robust hardware. Okay, this particular method, you are understanding what does that mean? If this particular method is inexpensive, you can easily use this method to identify your to ionize your given sample. Okay, so that is one thing occurring over here. And here in this particular slide only you can see that we have been provided with the spectra of lavendulyl acetate. Okay, and there are 3 different spectra of the same compound where there are different reagent gases that have been used. You can see in the first case in the top spectrum you can see the protonated molecular ion of lavendulyl acetate, that is this one, is barely visible. Okay, this one is barely visible, and the largest peak in this spectrum belongs to the fragment this one, that is one having mass by charge ratio 137. Understanding? So this one is your biggest abundant peak over here when you are using your methane as a reagent gas. See, if you are using your isobutane that is in the middle spectrum as a reagent gas, what is happening? 137 peak is still most abundant one, but this one is now over here. You can see the one that is your protonated peak. It is now somehow it is visible when you are using isobutane as a carrier gas. Okay, so fragmentation over here is still significant, though as the ion at mass by charge 137 is most abundant in the spectrum. It's still most abundant. Understanding? And you can see the third case where you are using ammonia as a reagent gas. So you can see now this particular protonated ion is going to have a most abundant peak, that is your at mass by charge 197. Okay, but you have to note the presence of an adduct ion, that is M plus NH4 plus. This is your presence of adduct ion in this particular spectrum. So you can see there is variation of all of your reagent gases, and due to which there is also variation in the spectrum that you can see. So different reagent gas is going to show different impact in your spectrum, just like that. So this is all about it. And yeah, we have one more technique to discuss over here in this particular method only, that is your DART, the chemical ionization used in the open air technique known as direct analysis in real time. So you can see the structure over here. What is happening? A reagent gas, usually helium or argon, is passed through a needle electrode with 1 to 5 kilovolt potential. Over here your gas can be passed from this particular needle, and it creating excited gas atom. Over here it is going to create excited gas atoms that collide with atmospheric water. That is like here it is colliding with your water molecule to generate protonated water cluster. In here you can see like in this reaction you can see the protonated water cluster has been created. This is what happened. Now what is happening? The sample is placed in the ion beam in any number of ways, including a wire screen, capillary or other solid surface. Collision between sample and this protonated water molecule transfer a proton to the sample like this. You can see. Okay, and the analyte molecule is then entering into the mass analyzer through the small orifice, and that is how you are going to detect your particular compound that is having with you. Okay, so these are the reaction, and whatever has been mentioned over here has been written as a reaction over here. So that is all about it. Your helium in the excited state is reacting with the water, forming your protonated water clusters like that, and this protonated water cluster reacting with your sample molecules, giving you this particular ion, M plus H positive ion, and just like that the reaction is over here. So that is all about chemical ionization method. Rest of the method we will be discussing in the next video. So that's all about it. Thank you for watching. Do like, comment, share the link, and subscribe the channel. Thank you.